Students, let us solve this Irodov problem number 1.49. A solid body rotates about a stationary axis so that its angular velocity omega depends on the rotation angle phi, as this is the equation omega equal to omega naught minus a into phi. This is the angular velocity and this is the angle where omega naught and a are positive constants. Okay. At the moment t equal to 0 means initial condition at time t equal to 0, the angle phi is 0. So at time t equal to 0, angle phi is 0. If I put phi is 0, then omega is omega naught. So initial angle is 0, but initial angular velocity is omega naught. We have to find the time dependence of the rotation angle phi and the angular velocity. So what is asked in the question is the equation of phi with respect to time, and in second part the equation of omega with respect to time. The given equation is with omega and angle. There is no time involved in this equation, and we have to find the equation of omega where time is involved and angle is not involved. So we have to calculate these two parts. How to do that? Now, this is a simple mathematical calculation. There is no physics in this. The definition of omega is d phi by dt, and it should be equal to omega naught minus a into phi. Now, d phi by omega naught minus a into phi should be equal to dt. Simply integrate these two parts. So integration of this part and integration of this part. The integration starts from time t equal to 0 where omega is omega naught, and at random time is t and angle is phi. Now what is the integration of this part? For that, integration of 1 by x dx should be equal to ln x. Okay. What is the integration of 1 plus 2x dx? It is simply ln 1 plus 2x divided by 2. What is the integration of 1 divided by 3 minus 2x dx? It is simply ln 3 minus 2x divided by minus 2. Now, on the basis of these results, I can write the integration of this part. So, the integration of this part is ln omega naught minus a phi divided by minus a from where to where, starting from omega naught to omega, and the integration of this part is very simple, it is t. Now put this omega, so it is ln omega, not omega, this is angle. The integration is with respect to angle and initial angle is 0. So from 0 to phi. Okay. So it is omega naught minus a phi minus ln omega naught, and it should be equal to minus at. So this is ln omega naught minus a phi divided by omega naught equal to minus at. Now write this expression in exponential form. So in exponential form, omega naught minus a phi divided by omega naught should be equal to e to the power minus at. So a phi is equal to omega naught minus omega naught into e to the power minus at. So the phi is omega naught divided by a minus omega naught divided by a into e to the power minus at. So this is the equation of angle phi with time. So this is my first answer. So the first answer is equation of angle phi with respect to time is omega naught divided by a, omega naught divided by a minus omega naught divided by a into e to the power minus 80. So this is the first answer. Now we have to calculate the equation of omega with time. How to do that? If I differentiate the angle with respect to time, I got the angular velocity. So differentiate this equation with respect to time. The differentiation of phi becomes omega equal to, this is a constant part, its differentiation is 0, 0 minus, this part vary with the time, but this part is a constant, so minus omega naught by a, and now the differentiation of e to the power minus 80. So the differentiation of e to the power minus 80 is, first e to the power minus 80 will remain as the same, and the coefficient of t is minus a, so it multiply with minus a. So this is the differentiation. This minus and this minus becomes plus, then this a will cancel out this a, so omega equal to omega naught into e to the power minus 80. So the equation of omega with time is omega equal to omega naught into e to the power minus 80. So this is the answer of second part.